2-7, solving absolute value inequalities. So the first thing we need to do is remember that, let me get my arrow here. We need to remember that less than is the and the way that we can remember that is less than. And so if we have absolute value of x is less than 5, remember with our absolute value equations we had two solutions. There are two possible numbers that could be in there that would come out with a value less than 5. And so we have to take that into account. So this results in a compound inequality here. And so we have -5 is less than x is less than 5. We keep those less than symbols there. For the or statement, we had our ors going in different directions. So we have x is less than -5 or x is greater than 5. Okay, opposite directions. And then the way that we can remember this, if it's greater than, it's or, it's greater than. So the or is in there, even though that's not how we spell greater. We're just stretching our imagination to help us remember these math rules. So remember with the absolute value equations, we had to have our absolute value bars isolated. So the first thing I need to do is get rid of all the extra stuff that's around the absolute value bars. So I'm going to -3 from both sides. I end up with the absolute value of x is less than 9. And so since it's less than, it's an and statement, I'm going to have -9 is less than x is less than 9. The way that we would graph that, if we have -9 and 9, remember this is going to be an intersection. These are open circles because they're not equal to, it says just less than. And this would be, if you reverse the statement, this would say x is greater than -9. And so if we're greater than -9, we're going to be going in this direction. If we're less than 9, we're going in this direction. And there's our intersection. So less than intersection. So this problem already has our absolute value bars isolated. So I'm going to go ahead and put my opposite sign for the 2. So -2, less than or equal to still because of the less than sign. It's an and statement. X plus 4 is less than or equal to 2. And so I have two things I need to solve here. So this combined, this is what I highlighted in the last video. We highlighted that x plus 4. That's that shared information that's happening here. So really we have -2, is less than or equal to x plus 4, and x plus 4 is less than or equal to 2. And so we can solve both of these. So -4, -6 is less than or equal to x. Another way you could write that is x is greater than or equal to -6, same thing. And here -4 and -4. And so we have x is less than or equal to -2. And so my final compound statement, I start with my smallest number, -6. I keep my less than symbols. It's equal to, in this case, x, which is less than or equal to -2. And then to graph this, we are at -6 and -2. This is less than, so it's going to be an intersection. And so I have my greater than or equal to, because I'm looking at this piece right here, x is greater than or equal to -6. Which is the same thing as -6 is less than or equal to x. And then I have my x is less than or equal to -2, and so close circles, my intersection. For the or statements, we have our absolute value x minus 8, and then plus 5 is greater than or equal to 11. So since this is going to be an or statement, I'm going to have to write two separate inequalities this time. Well, first I'm going to isolate my absolute value bars. It's always the first step, just like in the absolute value equation. So x minus 8 is greater than or equal to 6. And so my two absolute value inequalities now are going to be the absolute value, I'm sorry, we don't need absolute value anymore. Okay, it's going to be x minus 8. I'm removing my absolute value bars because I'm setting up my two statements right now. And I flip my inequality and the sign of my number. And then my other one stays the same. So x minus 8 is greater than or equal to 6. And so now we just go ahead and solve these. Plus 8, save a step here. x is less than or equal to 2, or x is greater than or equal to 6 plus 8 is 14. And so when I graph this, this should look like the oars on a boat again. Less than or equal to, so it's closed circle, and it's going to be going less than or to the left, so let's make that bigger. And x is greater than or equal to 14, so closed circle, going towards the right. Let's try another one of those. So we have absolute value of x minus 20 is greater, so my or, this is going to be an or. I always kind of remind myself too because I can so easily do this problem incorrectly. And so I need to isolate my absolute value first, so I'm adding 20 to both sides. Absolute value of x is greater than negative 13 plus 20 is 7. And so I'm going to write my two statements, my two inequalities for the or. So I have x, flip my sign, the inequality sign and the sign of my number, or what we had already there, so x is greater than 7. These ones don't even require solving. They've already been, x is already isolated as well. So we have negative 7 and 7 less than, greater than. So we're done.